What's up, people? I'm going to work some of these test review problems, all right? And we're going to do them. I'm not going to do every one. Okay, I'm just going to pick some to do. Let's try number one. Determine the number of grams. Now, see, we can only get this number of grams. We have to get the number of moles first. So that means this is definitely a Pivnert problem, right? Let's see, 450.6 milliliters. That's 0.4506 milliliters, right? Because that's milliliters. 1.8 atmospheres. Since we're using atmospheres, our R has to be 0.0821. And it says the temperature is 50.5 Celsius. So we're just going to say 50.5 plus 273. 323.5 is our temperature, and we're going to solve for N first, okay? Which means we'll take these two numbers, we're going to put them on the bottom, and that'll be our N. So I'm going to take my calculator, 1.8 times 0.4506 divided by parentheses, 0.0821 times 323.5 close parentheses equals 0.03 moles. 0.03 moles. And it says how many grams of carbon dioxide would that be? Whoopsie, sorry about that. So we'd say 0.03 times, we know that the weight of CO2 is 44. So okay, we have 0.03 moles, and it's times 44 grams per mole, 1.34 grams, something like that. That should make sense to you. All right, let's move on. Let's find one that might be, let's take a look at number 2. We'll just do that one. If you notice, it gives you liters, pressure, it gives you volume, pressure, temperature, and then again it gives you temperature and pressure. So we know that this is going to be the combined gas law, right? There's only really two formulas on this test. 2 liters is our first volume of a gas at 8 atmospheres of pressure. And the temperature is 900 Kelvin. That's good. That's in Kelvin. That helps us. And then I decrease the pressure to 5 and decrease the temperature to 750. What's going to happen to our volume? We're going to cross multiply, which is what the 8th grade teachers would call it in my day. So let's try it. 750 times 8 times 2 divided by parentheses 5 times 900, close those parentheses, equals 0.18. 0.18 liters. Okay. Pretty small. Let me check my math on that again. I don't know. 750 times 8 times 2 divided by parentheses 5 times 900, close parentheses, equals 2.7. I didn't think that number sounded right. 2.7 liters. I don't know what happened. You can probably play the video back and see where I made a mistake. All right. Let's keep rolling down here. How about number 6? Let's just do number 6 for the heck of it. Trying to pick some random ones. We've got volume, temperature, and temperature. Ooh, that is going to be, we can just use Charles' law. Or this is just the combined gas law. You just don't have to mention pressure because it doesn't change. 0.97 liters. 0.97 liters. That's 970 milliliters. At 29 Celsius, so that's 302 Kelvin. And then what is the volume at 132 Celsius? 132 Celsius is 273 plus 132, 405. We'll cross multiply. 405 times 0.97 divided by 302 equals 1.3. 1.3 liters. All right, so let's see. I like number 11. I'll do number 11 with you. You know why I like that one? It's just like the lighter lab. Number 11. It's going to be a Pivnert problem because it only mentions the pressure and things once. 0.003 moles, a 1 liter cylinder at 800 millimeters of mercury. Millimeters of mercury, we use we use 62.4 as our R. And would result in what temperature? Okay, so we're going to have to take these numbers, put them down here, 0.003 times 62.4. All right. Okay. So we'll be with 800 divided by, parentheses, 0.003 times 62.4, close parentheses, equals. Let's try that again. 800 divided by 0.003 times 62.4, close parentheses, equals. Something about this doesn't seem right to me. 0.003 moles. Maybe I'm just trying to work too fast. In a 1 liter cylinder. No, that is right. It would be super hot because it's very little gas to create that much pressure. Wow, 4,273.5 Kelvin. That'd be pretty dang hot, wouldn't it? I don't know why I don't like this. 800 millimeters of mercury. What, 0.003 moles in a 1 liter. Yeah, it's 1 whole liter. It's not. When we did the lab, we used 0.1 liters. So that's it. All right, let's keep rolling. We can try number 15, I guess. You might like to see number 15. Determine the number of grams of krypton. Okay, this is going to be a Pivnert problem. 8.25 liters, 7.8 atmospheres. Our R is going to be 0.0821 because of atmospheres. The temperature is 35.5, so that's 308.5 Kelvin. And we got to figure out how many moles we have first. So we're going to take these, and we're going to put them on the bottom over here, 0.0821 times 308.5. We're going to do that. We'll calculate this, 7.8 times 8.25 divided by parentheses, 0.0821 times 308.5, close the parentheses, equals 2.5 moles, 2.54 moles. And then the question says of krypton, so it says how much would that weigh? Determine the number of grams. So now we just say 2.54 times, we look at krypton, it's 83.8 grams per mole. So that's 213 grams, basically. All right, and then I'll show you some stuff on the back. You kids that are staying at home, you're not responsible for this. No, this isn't freshwater. What is the phase at 20 and 240? Now, I had some students say, hey, we can't read this. Well, these little dotted lines, David and I were talking about this, these little dotted lines are where they start over with a new scale. Okay, so the scale from 5 to 72, so you'd have to say 5 let's see, 10, 20, 30, 40, 50, 60. 20 is going to be about right here. So we're going to go over like this. And I'll give you a better question on your test. 20 atmospheres and 240 Kelvin. Man, that's so tough. It's going to be right in here. If you put liquid or gas, I wouldn't be upset. I will make your problem much more clear. This is not a good scale of your graph. If this worries you, look at the homework I gave you during class or the classwork, and you'll know how to do it. What is the phase at 1 and 300? It's going to put us right here. That's a gas. And it says, what's moving from 17 to 18? Well, if we said 17 was a liquid, if we said that was 17, and this was 18, then we'd say going from liquid to gas. You could call that boiling or vaporizing or even evaporating. I don't care. All right? And number 20, what are the conditions at triple point? Well, that's easy. It's 5.2 and 216.6. All right. Good luck, people.